everyone. Today's class is locked range PLL, capture range PLL, design rules or formulas for implementing PLL circuit and the list of applications of PLL circuit. So before going to start today's topic, already we are completed about PLLs. PLL, it stands for phase lock loop. So the PLL block diagram, it consists of main three blocks. One is the phase detector or phase comparator. Second one is the low pass filter, and third one is the voltage controlled oscillator. So PLL, the main aim of PLL is it is a closed loop feedbacking system. It will be used in multiplication, FM multiplier, and division purpose. So closed loop feedbacking system. Feedback is nothing but a direct connection established from output to input. Here in PLL block diagram, we are used as input is phase detector or phase comparator. Output is the VCO. VCO is nothing but voltage controlled oscillator. So a direct connection from VCO to phase detector. Next, PLL, after we are discussed about 565 and 566 ICs in previous classes. 565 IC is 14 pin IC. So 14 pins are used for, one is for ground connection, 2 and 3 pins are used for input purpose, 4th pin is for output purpose, 5th pin is VCO input, and say next pin is discharging, a external resistor, external capacitor, supply pin, and the 11, 12, 13, 14 pins are no connection pins. So main aim of 565 IC or the designing or need of 565 IC is in speed control motor system. Next, it also supports for demodulation, and also we are completed about 566 IC. The 566 IC, it will be used in mainly 566 IC, it will be used as voltage controlled oscillator. The voltage controlled oscillator, it matches the output frequency with input. So it is a closed loop feedbacking system. The output frequency will be matched whenever the output frequency will be matched with input voltage. So the circuit will be working on locked mode. If at all we are not applying any input, so no input is nothing but the circuit is in free running mode. If we are applying input, it is in capture range. So the VCO, it will be checks the output of voltage controlled oscillator will be matched with input of phase detector or phase comparator. So these are already we are completed in previous sessions. So now today's class is locked range. Today's class starts with locked range PLL, locked range phase lock loop. So lock range is nothing but once the phase lock loop is locked, it can track the frequency changes in incoming signal. So that is nothing but the range of frequencies over which PLL can maintain with the incoming signal is called lock range, or the output frequency will maintain the input signal is called lock range. That is nothing but once the PLL is locked, it maintains or it checks the input signal. It checks the or it can track the frequency changes in incoming signal. The range of frequencies over which PLL can maintain lock is called lock range, or it is also known as tracking range. The lock range, the frequency range of PLL is able to follow the input frequency variations once locked. So the locked range, it can check the input frequencies or it can able to follow the input signal. The lock range is nothing but the range of frequencies over which the PLL will track input frequency signal, and the remains it will be locked. It refers as PLL locked range. So it can check the frequency and it can also track with incoming signal in locked range. The frequencies over which PLL will track the input frequencies and remains it will be locked. The lock range is usually band of frequencies above and below the free running frequency. Free running frequency is nothing but in free running mode we cannot apply any input signal. So whenever we are applying input signal, it will be either above or below. That is nothing but it will be above is nothing but it is work on lock range or capture range. If at all no input is called free running mode. That's why we are defined that is the lock range is usually band of frequencies above or below the free running frequencies. Next, if the frequency of input signal is outside the PLL lock range, the PLL will not able to lock. So the frequency of input signal is outside the PLL lock range. Outside is nothing but the lock, whenever the lock range will arises is nothing but the output frequency matches with input frequency only, the lock range will arises. So the incoming signal is outside the PLL lock range, or the incoming signal and the output frequency will be different. So we cannot expect lock range, that is nothing but PLL will not able to lock. The output and input signals are different, so we cannot able to lock. Under this condition, VCO frequency means voltage controlled oscillator frequency will be jumps into fundamental free running frequency. So this is the diagram. In this diagram, first F0 is nothing but VCO free running frequency. So it is the capture range and lock range. So this is the beyond lock range. Next one is the capture range. VCO F0 is nothing but voltage controlled oscillator free running frequency. Voltage controlled free running frequency, when it arises means the incoming signal is outside the PLL lock range. So PLL will not able to lock, and under this condition VCO will be jumps into free running frequency or fundamental free running frequency. Next, after lock range we have another definition, that is capture range. Capture means observing, capturing. The range of frequencies over which PLL can acquire lock with input signal is called capture range. Range of frequencies PLL can acquire lock. So at which frequency it will be locked, or we can observe the frequencies is called capture range. In capture range of frequencies over which PLL can acquire lock. The capture range is always slightly smaller than lock range. If at all incoming is equals to outgoing, it will be is a lock range. So incoming and outgoing incoming and outgoing will be able to different, or it will be some other value. So it is known as capture range. If at all no input is nothing but zero input is called free running mode. So always the capture range is slightly smaller than lock range. Otherwise equals to lock range. So output is equals to input. Here the output and input values are different in capture range. The capture range, it observes the incoming signal. So the parameter is also expressed in as percentage of F0. F0 is nothing but output frequency. So the capture range will be expressed in terms of F0 also. Capture range is nothing but when the frequency within a PLL lock range is applied to the circuit will adjust and will remain in lock condition. When the frequency within PLL lock range is applied to circuit, so within PLL lock range is nothing but output is equals to input. The circuit will adjust, will remain in locked condition. So any deviation thereafter will be adjusted due to phase detector or low pass filter and voltage controlled oscillator functionalities. So any deviation, first we can adjust into lock range. So if at all any deviation or any changes in phase detector or low pass filter or VCO functionalities, once the input signal is captured, PLL will remain in locked state and will track the changes in input signal. So once the input signal is captured or input signal is observed, PLL will remain in locked state and will track the changes in input signal till it remains within a lock range. So PLL can observe lock range values. Capture range is nothing but the range of input frequencies over which PLL will capture the input signal referred as PLL capture range. So the range of input frequencies over which PLL will capture the input signal or phase lock loop will observe the input signal is referred as PLL captured range. So the narrow PLL capture in here the block diagram. So in the lock range is highest and capture range is narrower range. So the figure 2, the narrower compared to PLL lock range. So capture range is, here the capture range is narrow than lock range, narrow width. Cap range is broad and capture range is narrow and the lock range is broad. So the narrower compared to capture range is narrower compared to PLL lock range. Both PLL lock range and PLL capture range are centered around the VCO free running frequency. So PLL lock range and PLL capture range are centered around the VCO free running frequency. This is the VCO free running frequency F naught. F naught is the VCO free running frequency. It is the center, and next one is it will be covered with capture range. Capture range is nothing but input signal frequency, and lock range is equals to input signal frequency is equals to output signal frequency. F naught is the free running frequency. Capture range is the PLL input frequency. So the range of input frequencies over which PLL will capture the input signal referred as PLL capture range. Next, the capture range is narrower compared to PLL lock range. Both lock range and capture range are centered. Next, centered around the VCO free running frequency, voltage controlled oscillator free running frequency. PLL capture transient. Once PLL is locked, whenever the PLL is locked, the input phase detector or phase comparator value is equals to output of VCO, voltage controlled oscillator, or the output frequency is equals to input phase detector or phase comparator phase equals to output frequency, then only it will be is a locked state. Once the PLL is locked, it tracks the frequency changes of input signal. So whenever it locked in, then only it can change, it can tracks or it can observes. It can track or it observes the frequency changes in input signal. Next, it will be goes on 3 stages. First one is the free running, second one is the capture, and third one is the locked range. Here we can observe unlocked range. Unlocked range is called free running range. Free running range is nothing but here we cannot apply any input. Input starts from here only. Input starts from here. The pink spot it observes as input signal or input frequency change starts here. So that's why this is the unlocked range. Next, capture range. Capture range is nothing but we are applying some input to the signal. Next, lock range. In lock range, the input is equals to output. Input frequency is equals to output. Low pass filter output is equals to input frequency. This is the locked range. In unlocked range, no input is applied. In capture range, some input is applied, capture transient. In locked range, output is equals to input. So above figure it shows the capture transient of low pass filter. It controls the capture range. And if the difference signal Fs minus F naught, Fs is nothing but input signal frequency, F naught is the output frequency. So the low pass filter it controls the capture range, and if the difference is too large, it passes through low pass filter, the PLL will not respond. So the difference is nothing but input frequency minus output frequency will be high. The PLL will not respond if the signal is out of capture range. So but once the captured start, the PLL can lock or track the signal with beyond the capture range. So therefore tracking range is greater than capture range. In capture range, Fs minus F naught will be observed. Fs is nothing but input signal frequency and F naught is output signal frequency. The difference between Fs minus F naught is too high. The PLL will not respond. So it said that the signal is out of range or out of capture range. But once capturing start, whenever capturing start, Fs and F naught value will be, the difference between Fs and F naught value will be less. If at all it will be too high, the capturing will not capture, the capture range will not capture the signal and PLL will not respond. If at all Fs minus F naught will be low, so it will be starts capturing. PLL can track the incoming signal and the capturing start. Capturing mode, the tracking will be greater than capture range. So a PLL will be is basically on 3 states: capture range, locked range, free running range. Free running is nothing but no input, capture range is input signal. The range of input frequencies for which initially unlocked group will called capture range, the range of input frequency over which the initially unlocked loop will be locked at an input signal. In lock range, the lock range is also called hold in range. In lock range, the range of frequencies over which the loop will remain in phase locked mode with respect to the incoming FM wave, incoming frequency modulated wave. The range of frequencies over which the loop will remain in phase, that is nothing but VCO output is equals to phase detector input. So in this time it will be work on locked range, or the range of frequencies will remain in a phase with locked mode with respect to the incoming frequency modulator. Generally the lock range is larger than capture range because capture range is more difficult. In capture range we can observe the input signals, so the capture range is more difficult than locked range. Locked range frequency will be greater than capture range. So in this diagram also we can directly observe that. So capture range is less and the locked range is high, that is nothing but capture range is narrower. Next locked range is broad range. Next topic is design rules or formulas for implementing PLL circuit. The design rules, what are the rules we can follow the implementing or working of PLL circuit? So first the design rules, first is nothing but the center frequency of PLL can be determined by free running frequency of VCO. Center frequency of PLL is nothing but here the center frequency F0. F0 is nothing but F out. The F0 will be determined by free running frequency of VCO, voltage control oscillator free running frequency, which is given by equation F out is equals to 1.2 by 4 R1 C1 hertz. So F out, frequency of output signal, F out is equals to frequency will be the units of frequency is hertz. The center frequency will be determined by using of free running frequency of VCO. F out is equals to 1.2 by 4 R1 C1. Here R1 is nothing but external resistor and C1 is nothing but external capacitor. So the 565 IC is in PL, 565 PLL can lock to track an input signal over it will be typically plus or minus 60% of bandwidth with respect to F out is the center frequency. So it can uses the bandwidth typically plus or minus 60% of bandwidth respective to the center frequency. The lock range FL, the lock range FL. FL stands for frequency of lock range. F suffix L. F is nothing but frequency. The suffix L indicating lock range, and capture range is nothing but FC. Frequency of capture range. Lock range and capture range frequencies of PLL is nothing but FL and FC of PLL is nothing but it will be followed by equations. FL is equals to, FL is nothing but lock range. Lock range is equals to plus or minus 8 into F out by V. V is nothing but voltage. So the lock range is equals to, lock range is nothing but it will be comparable with output frequency and incoming signal amplitude or incoming signal voltage. So FL is equals to plus or minus 8 into F out by V hertz. Next, where F out is nothing but free running frequency of voltage controlled oscillator. The frequency terms is, or the frequency units is in terms of hertz only. So where F out is equals to free running frequency of voltage controlled oscillator. Next, V is equals to plus V and minus V. Next, V normal voltage is equals to, so it will be vary between plus voltage to plus VCC to minus VCC. Voltage is units of voltage is nothing but volts only. Next, FC. FC is nothing but capture range frequency. The capture range frequency value will be plus or minus FL by 2 pi into RC2 1 by 3 plus or minus FL by 2 pi. FL is nothing but lock range frequency. 2 is nothing but digit numerical number 2. Pi is nothing but it value of pi is nothing but we are already know the 3.14. Phi is equals to RC2. R is nothing but external resistor, C2 external capacitor. So FC is equals to plus or minus FL by plus or minus FL by 2 pi into RC2 1 by 3. So the value it will be is equals to R is equals to 3.6 into 10 power 3. The value of resistance here is equals to 3.6 into 10 power 3. That is nothing but 3.6 kilo ohms. Next, applications of phase lock loop, where we can apply the phase lock loop, or where we can use the phase lock loop. So the main aim of phase lock loop, it will be used in demodulation networks for FM operations, demodulations and frequency modulation operations, frequency modulation and frequency demodulation, and it will be used in motor speed controls and tracking filters, speed control system, motor speed control system. It used in frequency shifting decoders for demodulation carrier frequencies, frequency shifting decoder. The frequency shifting decoders are used for demodulating the carrier frequency. Carrier frequency is nothing but FC. Next, it is used in time to digital converters. So time to digital converter is nothing but, and mainly it will be is an analog to digital, like, so time continuous analog signals is in where it will be vary continuously with respect to time. So that is nothing but it also used in A to D converters, PLLs. It is used in time to digital converters. Time to digital converter is nothing but it is the one of application of analog to digital only. Next, it is used for jitter reduction and skew suppression for clock recovery. Jitter reduction, skew suppression is nothing but it is used for noise reduction purpose in clock recovery signals. Next, PLL, applications of PLL. Another applications is nothing but AM detection. AM is nothing but amplitude modulation detection. FSK demodulation, frequency shift keying demodulation, amplitude modulation, and it also supports for frequency shift keying. Next to frequency modulation, frequency demodulation, frequency amplitude modulation detection, frequency shift keying. Next, frequency modulation, frequency demodulation, phase shifter. Next, computer modems. Next, modem is nothing but modulator and demodulator, modulating purpose and demodulating, modulating at input section and demodulating across output section. So computers, modems, TV and car radio tuners, TV and car tuning is nothing but voice tuning circuits, tone decoders, and also it will be used in signal synchronizer, frequency translation. So these are the main 10 applications: AM detection, frequency shift keying demodulation, phase shifting, TV radio tuners, tone decoders, digital converters, time to digital converters, demodulations, skew suppression in clock recovery. Next, PLL in signal synthesizer, frequency translation. So the PLL applications is nothing but the clock phase adjustment in microprocessor and time to digital converters, TDC. So this is a PD, phase detector, low pass filter. Next, amplifier, sensor, tone wheel, motor. So this is the applications. Clock phase adjustment in microprocessor, time to digital converters, frequency synthesizers, motor speed control testing, frequency modulation and demodulation, jitter reduction, skew suppression, clock recovery. So the main applications of PLL. Next, the PLL, it also works as a frequency multiplier. Multiply means it contains more than 2 signals. More than 2 signals only the multiplication is possible, or minimum 2 signals. So before only one signal the multiplication is impossible. Multiplication is nothing but we contain the input side 2 or more than inputs. So the frequency multiplier is an electronic circuit that generates an output signal whose output frequency is a harmonic of input frequency. Harmonic is nothing but multiple frequencies. So frequency multiplier is a electronic circuit. So it is one circuit that generates output signal. The electronic circuit, it will generate the output signal The output frequency means F naught is equals to, the output frequency F naught is a terms of harmonic of input frequencies. Harmonic is nothing but multiple of input signal frequencies. Multiple input signal frequency just we called as Fi. Output frequency we have denoted the symbol of F naught. So F naught will be is in the terms of nth multiple of Fi. N means here the harmonic multiple frequencies, n is equals to either 1, 2 or not only 1. So 1 is nothing but F naught is equals to Fi. F naught is equals to Fi is nothing but it is not working as a multiplier. So the multiplication starts from F naught is equals to 2 into Fi or 3 into Fi or n into Fi. That is nothing but in multiplier circuit, or multiplier is an electronic circuit. It generates output signal frequency is equals to input frequency. Multiple of is equals to not multiple of or harmonic of input frequency. So frequency multiplier consists of non-linear circuits. Linear circuits is nothing but the output follow input signal is called linear circuits. The non-linear circuit is nothing but output and input will be different. And the frequency multipliers, it consists of a non-linear circuits. The distance of the incoming signal is consequently generates the harmonic of input signals. So the output will be the distance of input signal is generating the harmonics of input signal. So this is the frequency multiplier. Frequency multiplier is nothing but it is electronic circuit. It is the output of frequency multiplier is depends on these are the output of frequency multiplier is nothing but it is the harmonics or multiples of incoming signal frequency. So output frequency is equals to harmonics of incoming signal frequency. Our output consists of non-linear circuit and the incoming signal is consist of harmonics of incoming signal. So here some quiz questions is there. Quiz questions is related to complete PLL 565, 566 or frequency multipliers, advantages of capture range, locked range. So some quiz questions is first we are discussed. First, free running multi vibrator. So in fifth unit we have timers and PLLs. Timers related to 555 timer. 555 timer it will be used as a stable multi vibrator, monostable multi vibrator, and it also used in timers are used in LEDs, tone generators. So first in this quiz questions we are complete information about the quiz questions are related to complete fifth unit of LIC subject. Fifth unit is nothing but timers and PLLs. First question related to timers. A free running multi vibrator is also called as stable multi vibrator, voltage controlled oscillator, square wave generator and pulse stretcher. So the free running multi vibrator is a voltage controlled oscillator. How we can define free running oscillator is a voltage controlled oscillator means the free running multi vibrator, it operates a frequency which is determined by external tuning capacitor and resistor. So the free running frequency will be determined by external resistor capacitor, that is nothing but RT and CT. On applying DC control voltage, the frequency can be shifted on either sides. The frequency deviation, so once we are applying frequency, the frequency deviation is directly proportional to the control voltage, hence it is called voltage controlled oscillator. The free running frequency deviation is proportional and it will be and the DC control voltage, hence it is called voltage controlled oscillator. Free running multi vibrator, it operates a free running frequency which is determined by external resistor capacitor. On applying DC control voltage, the frequency will be shifted either side. So the frequency shifting is directly proportional to control voltage. It is called voltage controlled oscillator. Next question. Match the list of 1 with list 2. So list of 1 it contains some message. List of 1 it contains some information before input frequency or input frequency, and list of 2 has some values. So match the list of 1 with list of 2, which represents the 3 stages of phase lock loop. So what are the 3 stages of phase lock loop? First, before input list of 1 it contains the before input frequency, when the input frequency, after the input frequency. And list of 2 first is the PLL locked range, free running state, capture mode. So what are the matching? Matching is nothing but first before input frequency is called free running state. So first answer is list of 2, second one. List of 2, second one. Next, when the input frequency will be applied. When the input frequency will be applied, it will be works on capture range. When input is applied, it will be work on capturing. Next, after the frequency will be applied, it will be phase lock loop. So when input, after the input frequency, when input is applied, after applying only it will be matches. So it is called lock range. No input, some input, and after input applying observations. So the answer is A. A is nothing but the A contains 1 will be matched with 2. That is nothing but before input frequency will be applied with free running frequency. Second one is nothing but second one is 3. When the input frequency will be applied with capture range, and third one is the after input frequency applied. It is called phase lock loop. So the total answer is A. A will be matches with 1, 2, 2, 3 and 3, 1. That is nothing but the explanation is before input signal is PLL is work on free running state. Once the input is applied, the VCO starts changing and PLL is set to be in capture mode. So once when we are applying input mode, it will be goes on changes the state. The VCO frequency start to changes and it will be work on capture mode. When the frequency VCO, when the VCO frequency, voltage controlled oscillator frequency continues to change until it is equals to input frequency. So the VCO continuously change the frequency, output frequency with equals to input frequency is called phase lock loops. That's why the answer is no input is called free running, some input is called capture range, after input is called locked range. What is the best, next question, that is third question. What is the best choice of IC packages used for experimental purpose? Best package or IC packages, it will be available in 3 states. Metal can package, that is nothing but it will be an ring structure, and one is the flat package, and third one is the DIP. DIP is nothing but dual inline package. These are the main 3 packages of IC availability. Metal can or metal, the structure of metal can is nothing but it is under ring shape or circular shape. Next, dual inline package, and the last one is the flat package. So what is the best choice of IC package is nothing but dual inline package. Why we can choose the best package as dual inline package means dual inline package are used and it is easy to mount. The mounting does not require bending or soldering of the leads. So easy to bend, the mounting easy to mounting, and it doesn't require any bendings or solderings, extra devices. Soldering is nothing but just we are soldering with external gun, so that is nothing but soldering gun or bending. So once we are bending is nothing but the components will be spoiled or the working will be different. So that's why dual inline package is the best package and it is easy to mount. Mount is nothing but easy to just put in the circuit. The mounting does not require bending and soldering. Mounting is nothing but just insertion in the device, easy to insert. So insertion doesn't require solderings. Any other solderings means any other soldering gun or bending. Next, a 555 timer is a monostable application mode. It can be used for. So 555 timer is, it will be used in monostable application. How it can used as pulse position modulation, frequency shift keying, speed control measurement, and last option is the digital phase detector. So a 555 timer in a monostable application is, it can be used as a speed control measurement. How we can tell it will be a work as in speed control measurement means, in monostable mode, if input trigger pulses are generated from a rotating wheel, the circuit will determine the wheel speed. Whenever it drops the below predetermined value, therefore it can be used in speed control measurement. So it will be work on triggering pulses are generated from a rotating wheel. The circuit determines the wheel speed. So wheel speed whenever it drops below predetermined level. In monostable multivibrator, the below predetermined level is the 1/3 VCC. So it can change the states from 1/3 VCC to 2/3 VCC. Whenever it below the 1/3 VCC, so it can change the state, that is nothing but below predetermined level, it can use as a speed control measurement. And the next question is, the output frequency of voltage controlled oscillator can be changed by changing the output frequency of VCO. It depends on the external tuning resistor, external timing capacitor, modulating input, or all the above mentioned D value. So the VCO will be, already we are know the VCO. VCO stands for voltage controlled oscillator. The voltage controlled oscillator, it depends on the external tuning resistor, that is nothing but RT, external tuning capacitor CT, input voltage, modulating input voltage VI. So the VCO output will be matches with input signal. So that's why we can choose the option as the all of above. So all of above is nothing but the output of frequency VCO is nothing. The output frequency of VCO F0 is equals to 2 into VCC minus VC. VCC is nothing but supply voltage and VC is the controlled voltage, and also CT is the external resistor, RT is the CT is the external capacitor, RT is the external resistor, and VCC is the supply voltage. The formula of VCO is nothing but output frequency of VCO is equals to F0 into F0 is equals to output frequency F0 is equals to 2 into VCC minus 2 into VCC minus VC, means supply voltage minus controlled voltage by external resistor RT, external capacitor CT, and VCC supply voltage. 2 into VCC minus VC by RT, CT, VCC. So from the above equation, it is clear that F0 is inversely proportional to RT, CT, and directly proportional to VC. VC is nothing but controlled voltage and inversely proportional to external resistor and external capacitor. So therefore the output frequency can be generated by changing either control voltage CT or RT. So it does completely depends on the output frequency. The output frequency VCO completely depends on the CT, external capacitor, RT, external resistor, and voltage control, modulating input voltage. So this is the VCO can be depends on the voltage, external voltage, external resistor, and external capacitor. Next question. How to obtain a desired amount of multiplication in a frequency multiplier. The frequency multiplier, the output of frequency multiplier is the harmonics or multiples of incoming frequency. F0 is equals to N into Fi. F0 is nothing but output frequency is equals to N number of signals into Fi is the input frequency. So how to obtain the desired amount of multiplication is nothing but first by decreasing the multiplication factor, or by increasing the input frequency, or by selecting the proper divide by n network, none of the above mentioned. So how to obtain is nothing but by selecting proper divide n network, the multiplication will be the desired amount of multiplication in frequency multiplier. To obtain desired amount of multiplication in a frequency multiplier, it requires the selecting of proper divide by n network. So that is nothing but the desired amount of multiplication can be obtained properly selecting divide by n network. For example, the output frequency f out is equals to, output frequency is nothing but it is the multiple of fn, or multiple is nothing but harmonics of fn. Here the multiple phi into fn. A divide by n is equals to phi network is needed. Here we can get phi is equals to n is equals to phi. So to obtain the multiplication in a frequency multiplier or desired amount of multiplication in a frequency multiplier, we can choose the selecting of proper divide by n network. This is the answer. So these are all about quiz questions. The quiz questions related to about multivibrators along with PLLs. Next, IC packages. Monostable multivibrator is used in speed control system. VCO output depends on resistor, capacitor and applied voltage. Next, desired multiplication factor can be obtained by selecting the divide in network. So these are all quiz questions. So today we are completed locked range definition, capture range definition, next design formulas for implementing PLL circuit, applications of PLL and PLL frequency multiplier. Lock range is nothing but output is equals to input. Capture range is nothing but when we are applying input, the output will monitoring is called capture range. Next, design rules. So capture range is narrow bandwidth, lock range is broad bandwidth. Design rules is nothing but in designing rules we can obtain the formula f out is equals to 1.2 by 4R1 C1. 4R1 is external resistor, C1 is the external capacitor. Next, PLL, it can obtain the tracking the input signal plus or minus bandwidth with respect to center frequency. So FL is equals to plus or minus 8 f out into f out by V. FL is equals to plus or minus f out by V. FL is nothing but frequency of locked range is equals to output frequency by voltage. Next, FC is capture range is equals to plus or minus locked range by 2 pi into RC2. Applications, AM detection, FSK, demodulation, phase shifter. Next, FM demodulation network, speed control systems, time to digital converters. Next, jitter reduction and skew suppression, clock recovery system, frequency shifter decoding purpose, demodulation in carrier, computer modulation and demodulation, TV, car, radio tuners, tone decoders, signal synthesizers, frequency translations. Next, main application is it will be used as a time to digital converter. Next, motor speed controls, multiplier, frequency multiplier. It is nothing but it is an electronic circuit. The output frequency is equals to nth signal of incoming signal. That is nothing but the output frequency is equals to multiple or harmonics of incoming signal frequency. So frequency multiplier is a non-linear device. Non-linearity is nothing but output doesn't follow input signal. So harmonics of the in frequency multiplier, it depends on the harmonics of incoming signal. So these are some quiz questions related to a free running multivibrator is called voltage controlled oscillator. So free running multivibrator is nothing but the output voltage will be depends on the input section, or any changes in the input section is proportional to output side. That is nothing but directly proportional. So it is called voltage controlled oscillator. Incoming no input is called free running. Some input is capture. After input lock range. IC packages will be in dual inline is the best package which doesn't require more soldering and leads, bending of leads. Next, monostable multivibrator will work on the speed control measurement. VCO changes depends on the external resistor, capacitor and applied input voltage. Control voltage VC. Next, desired multiplication will be by using of proper selecting of divide by n network. So these are all about today's class. Definitions, locked capture range. Next, along with formula, design implementing of formula. F naught is equals to 1.2 by 4R1 C1. Applications, AM detection, modulation, FM demodulation. Next, computer modems. PLL frequency multiplier is nothing but the output of it is an electronic circuit. Output will be depends on the multiple or harmonics of incoming signal. Along with some quiz questions. So next topics in this unit is the last topics are demodulation and applications. We can discuss the last topics in next class. Thank you all.